Hello, everybody. Welcome to Selenium for Beginners. My name is Rex Allen Jones II. In this video's tutorial plan, I will cover Java data types, Java variables, and Java operators. Data types serve as the foundation of data manipulation in Java. Variables are used for storing data values in a memory location. Operators are symbols that perform operations and return a result. If you are interested, you can download this presentation and automation code at tinyurl.com Java variables operators. Now, let's dive into Java data types. There are two types of data types for Java. We have primitive data types and class data types. Both data types are called many names, but I prefer to call them non-object and object. I will briefly cover the non-object data types in this video. However, the non-object and object data types were covered in my other video, part 1, Building Blocks for Selenium. The primitive data types have 4 categories: integer, floating point, character, and Boolean. Integer and floating point hold numeric data. Character hold text, while Boolean holds true or false values. Within these 4 categories, there is a total of 8 data types. 4 of those data types are located in the integer category: int, byte, short, and long. 2 of those data types are located in the floating point category: double and float. Character has 1 data type, which is char. And Boolean also has 1 data type, which is Boolean. The Boolean data type holds either a true or false value. Although there are 8 primitive data types, int, double, and Boolean are the most used data types. The int data type supports numerical values without a decimal, while double supports numerical values with a decimal. Boolean supports conditional statements that return true or false and can also be assigned a true or false value. Let's go over to Eclipse and get started with data types. Method name would be demo data types. Public void demo data types. We start by writing the data types: int, double, and Boolean. The data type makes sure we assign the correct type of data. We saw in our presentation slide that int supports numbers without decimals. Double supports numbers with decimals. Boolean supports true or false values. Next, we have Java variables. There are 3 phases of variables. We must name our variable, declare our variable, and initialize our variable. Let's get started with naming our variables. Java has a few rules for naming a variable. It can contain case-sensitive letters, numbers, $, and underscore. This rule is important because the variables are case sensitive. We make sure to enter an uppercase letter when it should be uppercase and a lowercase letter when it should be lowercase. The next rule, it can begin with the letter, $, or underscore. Most of the times, a variable begins with a letter. These two rules are what we can do with the Java variable. Now, let's see what we cannot do with the Java variable. The next rule, it cannot begin with a number. It cannot contain a space or special character except a $, or underscore. The only special character I've seen in a variable is an underscore. The last rule is it cannot contain a reserved keyword. A reserved keyword is reserved for special actions. They have a predefined meaning in Java. Here's a list of the 50 reserved keywords in Java. Notice our 8 primitive data types are included in this list. They have a special use for defining our data. Boolean, byte, char, double, float, int, long, and short. Next is variable declaration. Variable declaration is declaring a variable exists in our class. All variables are associated with a data type. That's why we see in our syntax, data type is written before the variable name. Variable name is the name of the variable being declared. Let me back up and explain syntax. Syntax is a set of rules that specify a combination of words and symbols. The words in this syntax is data type and variable name, while the symbol is a semicolon. Semicolons are written at the end of many statements to complete the statement. It's similar to a period at the end of a sentence. The last phase for variables is variable initialization. Variable initialization is when we give an initial value to a variable before the value is used in our program. There is a left side and right side of every variable initialization statement. The left side displays a variable name, while the right side displays an expression. An expression is a value assigned to a variable name. Let's go back to Eclipse and demo variables. I am going to add variables to the method name. We are going to start with declaring a variable. The variable name is always written after its data type. Our data types are int, double, and boolean. The names will be year for int, amount for double, and outcome for boolean. That's how we declare variables. Data type followed by a variable name and semicolon. When it comes to initializing a variable, There are two ways to initialize a variable. We can initialize a variable at declaration or after declaration. At declaration is when we assign a value on the same line as the data type and variable name. Int year equals 2034. After declaration is when we assign a value on a different line as the data type and variable name. Amount equals 2345. Either way is okay. Assigning a value at declaration or after declaration. Recall the comments regarding int, double, and boolean. Let's make sure the data stored in the variable is correct. We cannot assign any values other than true or false to a boolean data type. And the same goes for any data type. For example, an error shows up if I assign 20 to outcome. The error states cannot convert int to boolean. If I change 20 to include a decimal, the error changes to show cannot convert double to boolean. Let's print the values for each variable. Sysout, what year did you pay? Amount for gas. I hope that outcome is outcome. Let me add the test annotation to our method. Import. Let's run. What year did you pay $23.45 for gas? 2034. I hope that outcome is false. Next is Java operators. There are several types of Java operators, but in this video, I will cover 4 operators. First is the assignment operator. Second are the arithmetic operators. Third are the relational operators. Fourth are the logical operators. The assignment operator assigns a value to a variable. In this example, I have a variable name, equal sign, then expression. Sometimes a person may say variable name, but most of the times people say variable for short. There are times a person may say expression, other times a person may say value. All of those terms are used interchangeably in Java. The purpose is to store data in a memory location, so that data can be used later in your program. Arithmetic operators, addition, subtraction, multiplication, and division. Addition is a plus symbol that adds a value on both sides of the operator. The same symbol is also used for joining strings. We saw this example when printing to the console. Let's go back to Eclipse. The first print statement shows plus amount plus for gas plus year. These plus symbols are used to join the string written in red with the variable. The second print statement shows plus outcome. This is known as string concatenation. We also see the assignment operator 3 times when assigning a value to year, amount, and outcome. Subtraction uses a hyphen symbol that subtracts the right operand from the left operand. An operand is an object manipulated by an operator. Multiplication uses an asterisk symbol for multiplying values. Last but not least is division, which uses a / symbol for dividing the left operand by the right operand. These are the 4 main arithmetic operators. In addition to these 4 operators, Java also has a modulus operator, which uses a percent symbol to divide the left operand by the right operand, then returns the remainder. For example, 5 modulus 4 will return 1. 1 is the remainder of 5 divided by 4. The modulus operator is no big deal because most projects do not use this operator. However, we use an increment operator, which increases the operand's value by 1. This operator adds 1 to the value. That's why we see 2 plus symbols. A decrement operator decreases the operand's value by 1. We can use the increment and decrement operators as pre or post. Pre-increment and pre-decrement places the plus or minus symbol in front of the variable name. Post-increment and post-decrement places the plus or minus symbol after the variable name. The difference between pre and post is pre-increments and pre-decrements perform their operations before using the variable, while post-increments and post-decrements perform their operation after using the variable. Let's take a look at a couple of arithmetic operators. At test, public void, demo arithmetic operators. Let's assign a value to total by using the addition operator. Int total equals 3 plus 4. Then print the value. Sys out. What is the total of 3 plus 4? Run. What is the total of 3 plus 4? 7. Let's use the pre-increment operator. Int increment total equals plus plus total. Then print the value. Sys out. What is the new total after incrementing 3 plus 4. Let's run. The new total is 8 because 3 plus 4 equals 7. Then increment 7 by 1 equals 8. This is similar to 7 plus 1 equal 8. Next are the relational operators, which are used to compare values. There are 6 operators that verifies the relationship between the left operand and right operand. Equal to verifies if both operands are equal. In math, we use one equal symbol, but in Java, we use two equal symbols for equal to. Not equal to has an exclamation point and one equal symbol to verify if both operands are not equal. Greater than has a closing angular bracket symbol that verifies if the left operand is greater than the right operand. Greater than or equal to combines two symbols, the greater than and equal to symbols that verify if the left operand is greater than or equal to the right operand. Less than is an opening angular bracket that verifies if the left operand is less than the right operand. Less than or equal to combines two symbols, the less than and equal to symbols, to verify if the left operand is less than or equal to the right operand. Let's demo the relational operators. At test, public, void, demo, relational operators. This time, we are going to assign x the value of 5 and y the value of 25. Compare both values by printing is 5 equal to 25. X equal to y. We use two equal symbols. Relational operators always return a Boolean value of true or false. Let's write another print statement. Is 5 less than 25? This time, I use the values directly rather than using X and Y. An error will show up if we do not surround the variables or values with a parenthesis. The error states incompatible operand types, string and int. The string operand type is written in red. Is 5 equal to 25? While the int operand type is x that assigns a value of 5. Adding a parenthesis around x and y informs the compiler we are comparing two int types. Let's run. Is 5 equal to 25? False. Is 5 less than 25? True. Next are the logical operators. Logical and, logical or. Logical and has two ampersand symbols that return true if both operands are true. It also returns false if one operand or both operands are false. Logical OR has two vertical lines that returns true if one operand or both operands are true. It also returns false if both operands are false. Let's go back to Eclipse and demo logical operators. At test, public void demo logical operators. Assign 10 to X and assign 100 to Y. First, let's check the logical operator. Logical and operator. Sysout. Do you know if 10 and 100 is greater than 50? X greater than 50 and Y greater than 50. Are both operands true? No. So this statement will return false. Now let's check the logical operator. Copy and paste and operator, then modify the statement. Or two vertical lines, change and to R. Are both operands true? All we need is one operand to be true, and this statement will return true. Run. Do you know if 10 and 100 is greater than 50? False. Do you know if 10 or 100 is greater than 50? True. That's it for understanding Java variables and operators. You can download the presentation and the Java code at tinyurl.com. TinyURL.com/JAVAVARIABLESOPERATORS. Hello, everybody. Welcome to Selenium for Beginners. My name is Rex Allen Jones II. We are going to discuss the relationship between Java's classes, objects, and methods. In this video tutorial plan, I will introduce classes, objects, and methods, discuss the concepts of classes, objects, and methods, followed by a demo of classes, objects, and methods. If you are interested, you can download this presentation and code that I will demo in this video at https://java-classes-objects-methods. First, I am going to introduce classes, objects, and methods. Starting with the class. Class is created using the reserved word class. In this syntax, our reserved word is written in purple. Class name, written in white, identifies the name of the class. Java is built upon classes because a class defines the nature of an object. Therefore, a class forms the basis of object-oriented programming, which is known as OOP. Within a class, we can create objects, declare variables, and we can also declare methods. A method's body can include objects, variables, and all kinds of statements that perform an action. There's two ways to create an object. Both ways require the class name. The first syntax shows class name and an object reference variable on one line. Then the object reference variable equal new class name on the second line. A shortcut of this same syntax is placing both lines on one line. We see the class name followed by the object reference variable equal new class name. Notice there are two class names in both syntaxes. The first class name helps declare a reference to the object, while the second class name assists with allocating the new object. In a good written Java program, a method performs only one task. The return type determines the type of data returned from the method. If no data is returned from the method, then we use void. However, if data is returned from the method, then the return type will be a non-object or object data type. All methods have a name, and the name is used to call the method. The parameter list is one or more parameters that receive arguments. An argument is a value passed to the method. The parameters are declared just like a variable. Two or more parameters are separated by a comma. Last but not least, the method's body is where we write our code. Now, let's discuss the concept of classes, objects, and methods. With this illustration, car is our class. By definition, according to dictionary.com, a class is a number of persons or things regarded as forming a group by reason of common attributes. Therefore, a class contains a group of common attributes. Our car class will form a group of new cars. That group of new cars with common attributes are called objects. We have 3 new car objects. Each of these new cars is a template of the car class. That means objects have the same attributes as their class. In Java, we call those attributes members. A member can be a variable or method. There is a difference between an object and an object reference variable. New car, new car, new car are the objects, while coupe is an object reference variable. We can say object reference for short. Coupe is an object reference variable because it refers to the first new car object. The same goes for minivan and sedan, which refers to their object. In our industry, an object reference variable is mistakenly sometimes called an object. I can admit that I am guilty of also calling an object reference an object, although they are different. If you wanted to buy a new car, what's one of the main things you want to know? How much does it cost? We would use a method to calculate the cost. To calculate cost, we need to add the price and tax. Price and tax are data that's manipulated by the method. Let's take another look at the same concept of classes, objects, and methods, but in a different way. On the left side, we have a class and a method. On the right side, we have objects. Know what? I am going to bypass discussing classes, objects, and methods in this presentation slide, but discuss them later in our demo. Next, we will demo classes, objects, and methods. First, we will see how to create and use objects, followed by returning values to a method. Then we will finish with arguments and parameters. Let's start with how to create and use objects. In object-oriented programming, most classes have data and methods. The class is car. Data will be instance variables, int price and int tax. Our method will be calculate cost. Public void calculate cost, which has a task of adding the price and the tax. Int cost equal price plus tax. After assigning the value to cost, we print the cost by writing sys out. What is the car's cost plus cost? In a different class, we have a main method to create our objects. Car coupe, minivan, sedan. Coupe, minivan, and sedan are the type of cars. The data type is car, while the coupe, minivan, and sedan refer to the car type. Do you remember from the previous video, understanding Java variables and operators? We declare a double non-object data type and amount as the variable. Then initialize the variable with 2345. We can do the same with object data types. I'm going to take this one at a time and erase minivan and sedan. Then write coupe equal new car. The first line declares coupe as a reference to an object of type car. That's why we call coupe an object reference variable, because it is a variable that refers to an object. The second line creates a new car object and assigns a reference to coupe. These two lines can be written as car coupe equal new car. Let's create one more for minivan. Coupe and minivan refer to the car object. As a result, the car object is a template of the car class. So check this out. Since the car class has price, tax, and the ability to calculate the cost, coupe will have its own price. Coupe will have its own tax, and coupe will have calculate cost. The same with minivan. Minivan will have its own price, tax, and calculate cost. Objects are copies of a class, which allows each object reference to have its own copy. Therefore, we can write coupe dot. The dot operator provides access to its copy of variables and methods. Notice the IntelliSense shows price, tax, and calculate cost. This shows that we can assign values to price and tax. Coupe.price equals 14,000. Coupe.tax equal 1,000. Then call the calculate cost method, coupe.calculate cost. Here's what happens when coupe calls the calculate cost method. Our code will assign the price and tax to coupe. Call calculate cost method, add both values within the method, assign the value to cost, then print cost of coupe. Let me show you by debugging. First, we add a breakpoint by double-clicking the line or shortcut Control-Shift-B. A breakpoint is the blue dots in front of the line number. Let's debug. Debug has stopped at price. The coupe's price and tax are set to 0. F5 steps into our code. $14,000 is assigned to price. F5 again, and tax is assigned 1,000. Coupe is getting ready to call calculate cost method to add our price and the tax. F5 again, or step into, and now we see cost is assigned 15,000. Next, we print the cost of coupe. What is the car's cost? 15,000. The same happens for minivan. Let's assign 9,000 to the price of minivan. Minivan dot price equal 9,000. Minivan dot tax equal 1,000. Then we calculate cost for minivan. Remove the breakpoint and run again. Coupe is 15,000 and the minivan is 10,000. Next is returning values to a method. The key to returning values is return type. Return type determines the type of data returned by the method. Currently, void is the return type, which means our method calculates cost will not return a value. The return type can be any object or non-object data type. Let's go back to coupe and minivan. We see coupe and minivan each cause the calculate cost method. But what if we wanted to see the cost difference between both cars? How would we calculate the difference between coupe and minivan? We need to access the cost, but the cost is calculated in a separate class. We write return cost to access cost and return it back to both callers coupe.calculateCost and minivan.calculateCost. Notice the error. Void methods cannot return a value. We must change void to int because cost has an int data type. After returning cost, we need to assign the value. Let's assign coupe.calculateCost to int coupe cost. So when coupe calls calculate cost, the price and the taxes are calculated, printed, returned to the method, then stored in variable coupe cost. The same for minivan. We will store the cost into int minivan cost. Now we have access to cost for coupe and minivan. Let's calculate the difference between both cars. Sys out difference between cars cost equal coupe cost minus minivan cost. This print statement subtracts the cost of minivan from the cost of coupe. Let's run. What's the car's cost? 15,000 and 10,000. And the difference is 5,000. Next is how to use arguments and parameters. It's possible to pass one or more values to a method when calling the method. The values passed to a method are called arguments. To pass an argument, we place a value inside of the caller's parentheses. For example, let's say registration is also a cost to a car. We write the registration cost 1,500 inside coupe.calculateCost. The variable that receives an argument is called a parameter. A parameter is declared inside the parentheses following the method's name using a data type and variable name, int registration. Notice the error was removed from coupe.calculateCost to minivan.calculateCost. The method calculateCost int in the type car is not applicable for the arguments. It's not applicable because the caller has no argument while the method is expecting a registration value. Let's add 500 as the registration cost for minivan. Let's add registration to the calculation with price and tax. When coupe and minivan calls calculate cost, it will pass 1500 and 500 to registration inside the parentheses. So registration is included with the cost calculation. Let's run. The cost difference changed from 5,000 to 6,000. This is how we pass arguments to parameters. We pass more than one argument to a parameter using a comma. Add int price, comma, int tax, comma, as parameters. Add price and tax as arguments. 14,000 and 1,000 for coupe. 9,000 and 1,000 for minivan. Remove coupe.price. Remove coupe.tax. Minivan.price and minivan.tax. Run. We have the same results. Coupe is $16,500. Minivan is $10,500 with the difference of $6,000. That's it for the relationship between classes, objects, and methods. If you are interested, you can download the presentation and code at tinyurl.com/java-classes-objects-methods. tinyurl.com/java-classes-objects-methods. We are going to discuss the if statement and switch statement. Both statements are conditional statements. Conditional statements and loop statements are flow control statements. A flow control statement is a statement that directs a program's execution flow. The flow is determined by a condition or loop. Conditional statements execute a certain statement if the condition returns true or false, while loop statements execute a set of statements over and over depending on the condition. In this video, I will cover the conditional statements. Another name for conditional statement is decision statement. It can be called a decision statement because our program must make a decision when it meets an if statement or switch statement. Let's start with the if statement. Java provides three types of if statements. First is the if-then statement. Second is the if-then else statement. Third is the if-then else-if statement. The syntax for if-then begins with if condition. If is a keyword that always starts the if statement. The condition generates a Boolean result which returns true or false. After the condition is an opening curly bracket followed by a statement. This statement can be a block of statements that's only executed if the condition is true. A semicolon completes the statement. The second bracket is a closing bracket and only required if there is an opening bracket. Next is the syntax for if then else, which contains an if condition, statement, and brackets, just like the previous statement. However, this statement includes an else clause. After the else clause is a statement that can be executed. We see an if keyword, condition, opening bracket, statement, semicolon, and closing bracket. The same information that was already covered for if then statement, except the second statement. Now we get a better picture of the statements. If the condition returns true, then the first statement is executed. But if the condition returns false, then the second statement is executed. The else clause extends the if statement when the condition returns false. The last if statement is if then, else if. It looks like the previous statement, but there are some clauses before the else clause. We have a clause for else if followed by a condition. There's also a statement. Depending on our program, we may add more else if clauses with a condition and statement. We have an if statement, condition, opening bracket, statements, semicolon, and closing bracket. An else if statement extends the if statement. There are three descriptions that explains statement. The first statement executes if the first condition returns true. The second and the third statement execute if one of the else if conditions returns true. All of the conditions are evaluated using a top-down approach. For example, a top-down approach using this syntax evaluates the if condition. When the if condition returns a false result, then the program flow evaluates the first else if condition. After the first else if condition is evaluated, the program flow evaluates the second else if condition. The same top-down approach would continue if there were more else if conditions that returned a false result. Soon as a true condition is found, the statement associated with that true condition is executed, and the remaining conditions are not evaluated. If there are no true conditions, then the else statement is automatically executed. The else clause extends the if statement by operating like a default condition when all of the other conditions are evaluated and returned a false result. Now let's demo the if statement. Let's provide a test. Since the if statement is used to make a decision, we build our test by assigning a value to a variable such as int age equal 34. Start by writing if. We have the option of writing our if statement from scratch or use IntelliSense. You can click Control Space to bring up IntelliSense. We see an if and if else statement. I am going to select if, and you see the syntax is already designed for us. The condition will be our test where our program flow must make a decision. For our condition, let's go ahead and write if age equal 24. Remember from the 9th video, Java variables and operators? One equal symbol assigns a value like int age equal 34, but two equal symbols perform our test to verify if age equals a certain value like 24. In this test, age is not equal to 24. Next, we have our statement, which is also called a body. Sys out. What do we want our program to do? If age equals 24, then print age equal 24. Let's run. We do not see an output printed to the console because the condition was not true. The statement for if condition only executes if the condition returns true. This statement returns false. Let's copy and paste. Then change 24 to 34. Let's run again. Now we see an output because age is 34. However, writing two if conditions is not efficient for our program. Let's implement an if then else statement, which is more efficient. Copy and paste the code, then replace if age equals 34 with an else clause. Run. We get the same result. Age is 34. I prefer to use an opening and closing bracket, although they are optional. Personally, I believe the brackets make our conditional statements look more organized. Let's remove the brackets and run again. Age is 34. This is how an if then else statement works. We write if and a condition to test our variable. If age equals 24, then print age equals 24. But if it does not equal 24, then print age equals 34. There is a downside to the if then else statement. It is more efficient than the previous statement, if then. But the downside is the program flow only have two options, if condition and else statement. Next is the if then else statement, which gives our program many conditions. Let's use age as our variable again and write some conditions. If age is greater than or equal to 65, then print you are eligible to retire at age, which will be 65. Else, if age is greater than or equal to 20, you are not eligible to retire at age. Copy, paste. Else if age is greater than or equal to 13 and age is less than equal to 19, print You are a teenager. Else, sis out, you are not old enough to work at age. If you have not watched the Java variables and operators video, check it out, where I explain operators greater than or equal to, the and operator, less than or equal to, and the concatenation operator. Let's run. You are eligible to retire at 65. Change 65 to 40. Run. You are not eligible to retire at 40. Change 40 to 16. Run. You are a teenager, 16. The if condition is the main test and will execute its statement if the condition returns true. The else statements are additional conditions just in case the main test returns false. Else has a default statement just in case all of the conditions return false. Let's change 16 to 1. Add a breakpoint, then debug. F5 to step into our program. Age equals 1. Do you see how our first condition is highlighted and getting ready to be evaluated? When I step into our program again, the first statement will get skipped and the next condition will get evaluated. F5. Else if age is greater than 20. F5 again. The next condition, else if age is greater than 13 and age is less than 19. F5 for the last time. We'll finally execute the default statement. You are not old enough to work at 1. F5. That's one of the downsides to the if then else if statement. All conditions are evaluated until a match is found. When a match is found, then the program exits the flow. However, if a condition is not found, then the default statement is executed. That's it for all three if statements. If then else, and if then else if. Next is the switch statement, which does not evaluate all the cases like the if statement evaluates all conditions. The syntax for a switch statement begins with keyword switch and a variable name. After the required opening bracket, there is a case value followed by a statement or block of statements, then the break keyword. Keywords are also called reserved words. A switch statement has multiple case values, multiple statements, and multiple break keywords. The blue dots indicate there can be many more case values. After the case values, the switch statement has an optional default statement. For a lot of situations, the switch statement is more efficient than the if statement. Starting from the top, we see a variable name equals a value. For switch statements, Java does not allow the value to be a double or Boolean primitive data type. The value must be an enumeration, string, or primitive types, byte, short, char, and int. Switch checks the variable's value. All we add is the variable's name within the parentheses. After the variable's name, we have the opening bracket followed by the case values. The case values verify if there is a possible match for the value. If there is a match, then our program executes the associated statement. The semicolon completes the statement or block of statements. Next is the break keyword. The break keyword is optional, but I have never seen a switch statement without a break keyword. All of the statements at and after the matching case value executes if break is not available. For example, if case value 1 has a match and there are no break keywords, then case value 1, case value 2, case value 3, and the default statement will all execute. Therefore, the break keyword exits out of the program flow. Default is another optional keyword that should always be included in our switch statement. The statement for default executes if there is no case value match. Then we have the closing bracket. Now let's dive into our demo of switch statements. Let's imagine we have a track race. The contestants receive a medal if they come in first, second, or third. For our switch statement, we initialize the variable with the value int medal equals 3. Next, we write switch. Just like the if statement, we can choose to write our switch statement from scratch or use IntelliSense. I'm going to use IntelliSense by clicking Control space, then select switch. We change key to medal. So far, we have switch and our variable, which is medal. The purpose of switch is to test our variable by finding the value. Right now, we have hard-coded our value to be 3. However, our application would send a variety of values. So let's write those other values. Case 1. This means if the value of medal equals 1, then it will execute sysout 1 equal gold medal. Break would exit out of the program flow after printing 1 equals gold medal. We can add a case for as many options as we want. To save time, let's copy and paste. Then change case 1 to 2. 2 equal silver medal. Copy and paste again. Then change case 2 to 3. 3 equals bronze medal. The last thing we have is default, which catches invalid choices. If medal does not equal 1, 2, or 3, Then our program flow execute sys out no metal. We don't need a case and a value for default because the program knows if the other values are false, then execute the default statement. Let's run. 3 equals bronze medal. Change 3 to 2. Do you remember what happened with the if statements? Each condition was evaluated until a match was found. Look what happens with the switch statement. Place a breakpoint at switch metal and debug. We see metal has a value of 2, then step into, and our program flow goes directly to the statement for case 2. It bypassed case 1. Switch does not evaluate every case. Step into again, and here's the output. 2 equals silver metal. Now we are at break, which will exit the flow after execution. F5. Break is optional. But let me show you what happens when we remove all breaks. Change 2 to 1. Let's debug. Metal has a value of 1. F5, and execution goes directly to the statement for case 1. F5 again, and 1 equals gold metal. However, there is no break for case 1. So execution goes to the next statement for case 2. So execution goes to the next statement for case 2. The same process continues until we execute the default statement. F5, and we see 2 equals silver metal. F5, and we see 3 equals bronze metal. F5, and no metal prints to the console. Let me add the breaks back. Break, 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 and break. That's it for the switch statement. I mentioned the switch statement is more efficient than the if statement. That's true, but we should implement an if statement and not the switch statement for 2 situations. The first situation is when our test involves more than one value. Notice how our demo if then else branch tests for 3 values. Age is greater than or equal to 65. Age is greater than or equal to 20. Age is between 13 and 19. We cannot test for more than one value using a switch statement. For switch, we test for one value, metal equals 1. As a result, we should use the if statement when we have more than one value to test. The second situation is when we test for Boolean conditions or floating point values such as type double. Switch does not allow doubles. I would write double cost equal 98.76. Then change metal to cost. Notice the error states cannot switch on a value of type double. The same happens for Boolean. Boolean result equals false. Change cost to result. The error states cannot switch on a value of type Boolean. Only convertible int values, strings, or enum variables are permitted. Change result back to metal. Then comment double and Boolean. Cannot use type double. Cannot use type Boolean. You can download the presentation and the code at tinyurl.com java-conditional statements java-conditional-statements. Our tutorial plan will cover the following: how to name a package, how to name a class, how to name a method, how to name a variable, followed by questions, answers, and practice. The practice is always optional, but I know practice makes improvement. Let's start with how to name a package. In our previous sessions, I did not use a conventional naming standard for the packages. As we can see, there is a default package and a package called building blocks, which was created in our session Building Blocks for Selenium. Convention is a standard, but we do not have to use that standard. Know what? I am getting ahead of myself. Before we get into the package naming convention, give me a moment to explain package. What is a package? A package is a group of classes with two purposes for each class. Number one, a package is used to organize classes as a group. It is beneficial to the programmer when related classes are grouped together. Number two, a package is used to control access to the class. Classes can be defined as public to accept outside code and defined as private without an access modifier to prevent outside code. All classes belong to a package. In Eclipse and our screenshot, we see a default package with three classes: data types, print statements, and system.setProperty. By default, classes are placed in the default package when no package name or package statement is provided for that class. When a package name is provided, that class is placed into a particular package. In this example, building blocks is the package, while search t-shirts test ng, and search t-shirts highlight are the classes. The compiler does not allow two classes to have the same name in the same package. However, two classes can have the same name in different packages. It is expected for packages to be written in all lowercase letters. To create a package, right-click Source, which is SRC, select New, then Package. A warning or error message will show up if we start with anything other than a lowercase letter. Watch what happens when I enter a special character. Invalid package name. If I enter a dot, the message states a package name cannot start or end with a dot. A warning shows up if we enter a capital letter. Discourage package name. By convention, package names usually start with a lowercase letter. Notice it did not show an error, but a warning that stated it is discouraged. Why is it discouraged? One of the reasons why it is discouraged because all lowercase letters for a package name separates packages from a class, a method, and a variable. By convention, a class, method, and variable can have uppercase as well as lowercase letters. Now, let's dive deeper into the naming convention for a package. Many organizations use their internet domain for their package name, but in reverse order. For example, I have a domain called seleniumforbeginners.com. Currently, there are no articles or videos on this site, but it's available as a domain. As a package name in reverse order, I would write com dot then selenium for beginners. The same is true for testng. If we look at class search t-shirts testng, the import statements start with org.testng. That is the reverse domain for testng.org. Go to a browser and type testng.org. Here is the website for testng and the book I suggested at the end of video part 2, Building Blocks for Selenium. We can add related sub-packages and classes under com.selenium for beginners. I am going to add 3 sub-packages: Java, Selenium testng, and utility. Although there will be sub-packages, a class is still allowed to be added under package, and of course the sub-packages. A sub-package is created using a dot. Right-click the package, select New, then Package. At the end of the package name, add a dot. Then write Java. Let's add 2 more packages. Go to New, Package. Replace Java with Selenium underscore test ng. One more time, replace the existing subpackage name with the new subpackage name. Utility. Now there are 3 subpackages under com.selenium for beginners. It does not look like 3 subpackages due to the package presentation. Currently, the presentation is flat, but we will change it to hierarchical. Select the drop-down arrow, package presentation, hierarchical. Personally, I like this presentation better than flat. We will add classes only related to Java under the Java package. Classes that involve Java, Selenium WebDriver, and TestNG will be added to the Selenium underscore TestNG package. Utility is a common package which consists of common functionalities. Let's consider the definition of utility. According to dictionary.com, it is the state or quality of being useful, something useful. Therefore, we can use the utility package for adding classes that we are going to reuse over and over. For example, I pre-wrote a class called Highlighter, which highlights web elements. It will highlight the web element before performing an action on the web element. Highlighting an element is very good for demos. I am going to show you how it works using Search T-shirts highlight class. First, let's execute without highlighting the elements, then execute highlight the elements. Run the Search T-shirt test ng class. Now, execute Search T-shirts highlight. We saw each element got highlighted before an action is performed on the element. I am going to move the highlighter class from one package to another package. We don't need 2 utility packages. Watch what happens. Let's go to Search T-shirts, highlight. The import statement shows utility.highlighter. Utility is the package and highlighter is the class. I am going to drag highlighter to the other utility package. The Move dialog has a checkbox that states Update references to highlighter.java. Click OK. And the import statement has been updated to show com.seleniumforbeginners.utility.highlighter. We see the package, subpackage, and highlighter class. Speaking of classes, how to name a class. By convention, a class name is a noun that starts with an uppercase letter. If there are two or more words, then each word starts with an uppercase letter. This format is called upper camel case. Let's go to the Java package, right click, select new, then class. Classes can include uppercase and lowercase letters, but it is discouraged to start with a lowercase letter. If I type a lowercase c, the message states type name is discouraged. By convention, Java type names usually start with an uppercase letter. Classes can also include numbers and underscores. I have seen underscores in a class name, but I am not sure if I have seen numbers in a class name. However, an error shows up if we start with a number, but an error will not show up if we start with a hyphen. I have not seen anyone start a class with a hyphen, although it's valid. If I type a hyphen, no warning or error shows up. But when I type a number, an error states type name is not valid. Someone may ask or wonder, why does the warning and error messages keep saying type name? Type name is not valid. Java type names usually start with an uppercase letter. The messages continue to show type name because classes are data types. Remember this slide from Building Blocks for Selenium? It showed two data types. Primitive, which has many names such as non-object, and class, which also has many names, but I prefer object. This slide shows class is a data type. That's one of the reasons why the messages shows type name. A class definition always creates a new data type. In our example, to define conventional names as a class. Next, we have methods which are written inside of a class. How to name a method. Before speaking about conventional names for a method, let's discuss how to declare a method. A method is declared with 6 components: access modifiers, return type, method name, parameter list, exception list, and method body. We will bypass exception list. First, we have access modifiers, which determine how a method is accessed. Protected, private, and public are the modifiers. Private and public are the most used modifiers. Private means the method can only be accessed by members within the same class. Public means the method can be accessed by any class from any package. Second is the return type. Return type dictates the type of data returned by the method. Remember this slide? It shows the most used data types. If we have a return type of string, then the method expects a return data type value of string. The same for the other data types such as int, double, boolean, and any class data type we create. However, if the method does not return a value, then we write void. Void means no return value is expected from this method. Next is the method name. By convention, method names follow a lower camel case syntax, where the first word is lowercase, then each subsequent word is uppercase. Most of the times, method names are verbs or verb phrases. A verb phrase consists of a verb and its dependents, such as an object or complement. We are going to name our method demo conventional names. All methods have a parenthesis after its name. The method's name and parenthesis are called the method's signature. Parameters are included inside the parentheses if arguments are passed to the method. A parameter is the data type and variable which we will talk about next in how to name a variable. Parameter list is one or more data types and variables separated by a comma. The parameter list remains empty if there are no parameters. A method's body starts with an opening bracket and closes with a closing bracket. The brackets can open on the same line after the parenthesis. However, I prefer to open my bracket on the next line. Personally, the body looks neater and more organized when it's opened on the next line. The body contains one or more statements. Code that performs an action is considered a statement. Also, variables are considered statements. How to name a variable. Variables are declared with a data type and name. The name can be an unlimited number of characters. Nevertheless, there are some rules and conventions for naming a variable. Three of the rules are: 1. It can contain letters, numbers, $, and underscore. 2. It can begin with a letter, $, or underscore. 3. It cannot contain a space or special character except $, or underscore. Three of the conventions are: number 1, construct a descriptive name that describes the variable's purpose. Number 2, compose names utilizing the lower camel case syntax. All the letters are lowercase if there is only one word. Number 3, create a name that begins with a letter. Let's go back to Eclipse. We will write the data type, then the variable name. In this case, our data type will be int, and variable name will be number of years. The goal is for variable name to be descriptive so our teammates can understand. We want to make it easier for ourselves and other people to read our code. The variable name can be written as NYR. But why not add a few more letters and write number of years? Perhaps an automation engineer wants to abbreviate the variable. That's fine too. It's better than writing NYR. We can write string cust name rather than writing the entire words customer name. If multiple variables have the same data type, feel free to write the new variable on a separate line or on the same line, separated by a comma. In closing, I failed to mention Java is a case-sensitive language, somewhat like passwords. An error will show up if we mistakenly write a lowercase letter instead of an uppercase letter, or vice versa. For example, if we plan to use number of years in another part of the program, the compiler will display an error if we write an uppercase N for number or lowercase y for years. In spite of that, these are the conventions for packages, classes, methods, and variables. We are not forced to follow the conventions. However, we are forced to make sure our names are not reserved words. A reserved word has a predefined meaning and set aside for special use. A few reserved words in our program are boldface and written in purple. Package, public, class, void, and int. Here's a list of the 50 words reserved for Java. I highlighted the same 5 words from our program. Class, int, package, public, and void. A summary of our conventions discussion is located in this table. For package, all of our letters are written in lowercase. Classes are usually nouns written in camel case syntax. Methods use verb phrases with a lower camel case syntax. Last but not least, we have variables that are descriptive and also written in a lower camel case syntax. Questions, answers, and practice. Number 1, how do you create a sub package? Number 2, can a class name include numbers? Number 3, what is the convention for a method? Answers. Number 1, how do you create a sub package? A sub package is created using a dot after the package name. Number 2, can a class name include numbers? Yes, a class name can include the numbers, but it cannot start with a number. Number 3, what is the convention for a method? The convention for a method is to follow a lower camel case syntax by way of a verb phrase. Practice. If you have time, watch this video conventional naming in Java at least one more time. Create some sub-packages that include a utility sub-package. Read the code from Search T-shirts highlight and see if you understand how to highlight web elements. If you understand how to highlight web elements, then highlight each element in your test script verify demo web shop email logout. To download the PowerPoint slides and automation code, which includes highlighting the web elements for demo web shop, go to conventional naming in Java. https://tinyurl.com/conventional conventional hyphen naming hyphen in hyphen java. Enter. Thank you for watching Conventional Naming in Java. Hello everybody. Welcome to Selenium for Beginners. My name is Rex Allen Jones II. We are going to discuss loop statements in Java. Click the like button and subscribe to this channel. After clicking subscribe, click the bell icon to receive notification of each video. The video transcript, presentation, and code can be downloaded at tinyurl.com/java-loop-statements. Loop statements are control statements which control a program's flow of execution. All loops execute a set of instructions over and over while a condition is true. Java provides three ways to execute a loop statement: the for loop, while loop, and do while loop. The for loop executes a statement after initializing a variable, adding a condition, and setting an iteration expression. The while loop checks for a condition, then determines if a statement should be executed. But the do while loop executes a statement first, then checks a condition to determine if it should continue executing the statement. Let's demo the for loop. We will start by writing two print statements: sysout start for loop, sysout stop for loop, \n. The \n is used for skipping lines. Both print statements will be our indicator when the loop starts and stops. Next, we write for, then control the space, and select the first option. Modify the statement I less than array.length to I less than or equal to 10. The keyword for starts the for loop. We have three statements within the parentheses separated by a semicolon. The first statement is int I equals 0. Second statement is I less than or equal to 10. And the third statement is I plus plus. Int I equals 0 is an initialization which sets the initial value of the loop control variable. In this case, the loop control variable is I and will start at 0. The first statement operates like a counter that controls the loop. I less than or equal to 10 is a condition. This condition is a Boolean expression that determines if the loop repeats or not. The loop repeats if the condition is true, but does not repeat if the condition is false. Our loop starts at 0 and stops when the condition is less than or equal to 10. R++ is an iteration. An iteration defines the number of times the counter variable changes after each loop. This iteration will increment by 1. Therefore, the counter variable, which is I, will increase by 1 after each loop. I++ is short for I equal I plus 1, which adds 1 to I. The short version of I equals I plus 1 is I plus equals 1. All the three versions add 1 to I. However, the default and conventional way to write an iteration is I++. Last is the body. Sys out I equal append I, which is a statement that will get executed when the condition is true. Let's run. The counter variable starts printing at 0 and stops printing at 10. The condition keeps checking until I is less than or equal to 10. I'm getting ready to show you through debug so you can see how the for loop operates behind the code. Add a breakpoint at line 14, debug. We see execution stop at the for loop. Watch the starting value get set to 0 after I step into. So far, the starting value has been set and our program verified 0 is less than 10. Since the condition is true, execution stopped at the print statement. Step into, and I equals 0 is printed to the console. Execution is back at the for loop. Our program is now finished with the initialization statement int I equals 0. From this point, the focus will be on the condition and iteration. Iteration I++ will increment the value by 1, then check the condition and verify if the value is less than or equal to 10. Step into, and I is set to 1. Step into again, and the console shows I equals 1. It will continue this same process of incrementing the value and checking the condition until counter variable I is no longer less than or equal to 10. I'm going to step into until I equals 10 using F5. 2, 3, 4, 5, 6, 7, 8, 9, 10. Now when I step into, the program will exit the for loop. We see stop for loop is highlighted. Step into for the last time. Then we see the console shows start for loop, counter variables 0 to 10, and stop for loop. This for loop shows what happens when the condition is true, but look what happens when the condition is false. Change the condition to greater than or equal to. So starting out, 0 is not greater than 10. Let's run. All we see is start for loop and stop for loop. The loop started and stopped, but the code inside the for loop did not execute because the condition is false. By mistake, we can create an infinite loop. An infinite loop is a loop that never terminates because the condition is always true. For example, let's change the starting value to 20. This condition remains true because starting out, 20 is greater than 10. Let's run. Do you see what's happening in the console? Execution will never stop, so we must click the red button to terminate our execution. Let me change the value 20 to 0 and make the condition less than or equal to. I have a question for you. How would you count backwards from 10 to 0 using the for loop? We must use the decrement operator. Sysout start for loop. Sysout stop for loop. \n. For, then a parenthesis, and both brackets. Within the parentheses, I'll write the initialization statement int x equals 10 and a semicolon. This makes our starting value 10. Next is the condition x greater than or equal to 0 and a semicolon. The first check will be true because 10 is greater than 0. Last is the iteration x minus minus, which will decrease the counter variable. Execution statement is sysout x equals append x. Let's run. We see x starts at 10 and stops at 0. If you wanted to decrease the value by number greater than 1, you can write x minus equals 2 to decrement by 2. Let's run. And you'll see what happens. The console shows 10, 8, 6, 4, 2, 0. That's it for the for loop. Let's demo the while loop. Sysout start while loop. Sysout stop while loop. \n. Start by assigning a value like int counter equals 0. Then write keyword while, which begins the syntax. We have the option of writing our while loop from scratch or use IntelliSense, control space, and select the third option, while loop with condition. From scratch, we write while, then a parenthesis and two brackets. It will execute sysout counter equals counter over and over depending on the condition. Let's write while counter is less than 100, print counter equals a value. However, if I execute now, this while loop will create an infinite loop. The iteration step is missing, so the code will never terminate. Let me show you. See how it keeps running? We stop the loop by writing counter plus plus to increment counter by 1. We have initialized the counter variable to 0, and the loop repeats as long as the value is less than 100. The counter increments every time after printing the execution statement. Do you know what the last counter value will be since condition is less than 100? Let's run. The last value is 99. Soon as the counter value reaches 100, the program stops looping and exits the while loop. Recall from the for loop that plus plus is short for plus 1. Therefore, counter plus plus can be written as counter equals counter plus 1. Run again. Another shortcut is plus equals 1, which will give us the same result. Let's increment by 10, then run. The last value is 90. I want to show you a false condition by changing less than 100 to greater than 100. 0 is not greater than 100, so the counter print statement will not execute. We see the while loop started and stopped, but no execution statement. Change back to less than 100. That's it for while loops. Let's demo the do while loop. Write two print statements. Sysout start do while loop. Sysout stop do while loop. Initialize the loop variable by writing int y equals 0. Next, write the keyword do, which begins the syntax. Control space and select the do while statement. I'm going to add sysout y equals plus y within the brackets. Then y plus plus as the iteration so the loop can stop. The while condition is written after the loop's body. We want to execute the body while y is less than or equal to 20. The do while loop will execute the print statement at least one time before checking if the condition is true or false. If the condition is false, then the body executes one time. I'm going to make the condition false by changing the starting value from 0 to 100. Here's the breakdown. The do keyword starts the loop, executes the print statement by printing y equals 100. It's only supposed to execute while y is less than or equal to 20. So this statement will not execute anymore. Let's run. We see the do while loop start and execute y equals 100 one time before stopping. Change 100 back to 0, then run. Y starts at 0 and stops at 20. We set the value to 0. Started the loop by writing keyword do. Added a print statement for execution. Incremented the value by 1. Then checked for a condition while y is less than or equal to 20. That's it for the do while loop. Let's recap all the 3 loop statements. The for loop starts by writing keyword for with 3 statements. The first statement is initialization, which sets the counter variable. Counter variables can also be called loop variables because it is a variable that controls the loop. We have to make sure to complete the initialization statement with a semicolon. The second statement is a condition. A condition is a Boolean expression that determines if the loop will repeat or not repeat. If the condition is true, the loop will repeat, but it will not repeat if the condition is false. The condition also ends with a semicolon. However, the third and final statement is iteration, which does not have a semicolon. We can increment or decrement the counter variable after each loop. Next, we have an opening bracket, followed by a statement or block of statements, then a semicolon. The closing bracket complete the for loop. Let's use the flow chart because some people get a better understanding watching the flow. We start by writing for, followed by an initialization. After the initialization is the condition. If the condition is false, then that stops the for loop. However, if the condition is true, then our body, which is a statement, is executed. Next, we have an iteration before going back to the condition. The loop repeats until the condition is false. The while loop starts by writing keyword while and a condition. An initialization statement is not in this slide, but it helps the condition determine if the while loop should repeat or not repeat. The condition can be any Boolean expression. We have an opening bracket, then our statement body, and a semicolon. Notice how the condition is checked at the top of the loop before writing a statement. The statement is only executed if the condition is true. One more bracket closes the while loop. Here's while loop flowchart, which starts with while. First, we see the condition. If the condition is false, The while loop bypasses execution and stop. If the condition is true, the while loop executes a statement, then increments or decrements the value. Next, the process continues all over again until the condition becomes false. Last is the do while loop, and it starts with keyword do, followed by an opening bracket. Then we have a statement and a semicolon. This guarantees the statement will get executed at least one time. After the statement is a closing bracket, keyword while, and a condition is last. Notice how the do while loop is different from the for loop and while loop. The condition is at the bottom of the loop, but the for loop and while loop has a condition at the top of the loop. The flowchart also shows keyword do and a statement. Statements automatically gets executed once before an iteration. After the iteration increments or decrements a counter variable, we have our while condition. If the while condition returns false, then the program stops running, but it will keep running if the while condition is true. The do while loop continues executing, iterating, and checking the while condition until false is returned from the condition. Java is flexible when it comes to loops. How do you know which loop to use for a certain task? I recommend using the for loop when you know how many times the loop should run. The while loop should be used when you do not know how many times the loop should run. The do while loop is used when the loop must run at least one time. That's it, and thank you for watching Java's loop statements. If you are interested in the transcript, presentation, and code, go to tinyurl.com/Java loop statements. https://tinyurl.com/loop statements. Hello and welcome. My name is Rex Jones II. In this video, we are going to look at the enhanced for loop, also known as for each loop. The purpose of this loop is to cycle through a collection of objects. First, we need a collection. The collection will be an array, int number. Initialize the array to 1, 2, 3, 4, and 5. Next, we add a variable called total and assign it to 0. This will hold the total of the array. Now here's the enhanced for loop. We can write for, then control space, and select for each. This is the fast way, but let's write it from scratch and walk through it step by step. For parentheses, the enhanced for loop accepts 3 parameters in the parentheses: the type, iteration variable, and collection. Int is the type of data, and it matches the same type as the array, followed by an iteration variable. Let's make the iteration variable num. Num receives all of the elements from the array when looping through the array. Then we have a colon, and the name of the array, number. Number is the collection that will be cycled through. Next is the loop's body. Print the numbers, sys out, number, num. We can write the total. Total plus equals num. This statement will take each element 1, 2, 3, 4, and 5 and add the value to total each time it loops. So 1 gets added to 0, 2 gets added to 1, and it will continue until we have 15, which is the total of all of these numbers. Let's go ahead and print the total. Sys out, add hyphens, skip a line, total. Execute the program. $15. That's it, and thank you for watching how to implement an enhanced for loop. Java programs perform I/O through streams. I/O stand for input, output. You know how we print to the console using system.out.println? That's part of Java's I/O system to produce information. We can also use the I/O system to consume information. There are 3 streams defined in the Java I/O package to read data or write data. The streams are byte, character, and predefined. Byte is defined by 2 class hierarchies, input stream and output stream. Character is also defined by 2 class hierarchies, but those classes are reader and writer. Reader is used for input and writer is used for output. This is a list of the byte streams and character streams. The original Java version only included the byte stream. However, the character stream was created to parallel the corresponding byte stream. This list came from Oracle's site. Number 3 is the predefined stream, containing the system class with 3 fields, in, out, and System in refers to the standard input, which defaults to the keyboard. System out refers to the standard output, which defaults to the console. System refers to the standard error, which also defaults to the console, just like system in. We are going to focus on the character streams that was designed to handle input and output characters. This session will cover Java's output. For starters, let's print the current path directory. String path directory equal system.get property user.dir sysout path directory and run. We see the directory in the console. System.out is an object of type print string which contains print and println that contains aspects of the runtime environment. Now it's time to write to a file. PrintWriter is a class that allows us to print on the file. Object write equal new print writer. We see some constructors. File is the one we need. Which file are we printing to? Write file test.txt. This will be the file name. Add a throws declaration of IO exception. System out is very similar to print writer. Look what happens when I type write.pri. Do you see the print statements? Select print ln. The difference is system.out prints to the console and print writer prints to a file. First line, Joe Doe. Second line, software tester. And last line will be 10 years experience. We must always close at the end. Write.close. Close releases the file for other system resources in the operating system. Open Package Explorer and run. We see Write File Test in the Package Explorer. Open the file and the information is correct. Joe Doe, software tester, 10 years experience. The purpose of this video was to give you an example of how to handle output characters in Java. Next, I will show you how to handle input characters. We are going to read from a file using some of the code from Java output. Get the path directory. Then write file equal new file. Read file test.txt. This statement represents the file we are going to write to. Therefore, we change the file name write file test to file. If you want to, you can replace file with new file read file test. I wanted to separate them on different lines. Let's add some more data. Copy, paste, and change Joe Doe to Jane Doe. Change software tester to automation tester. How about 10 years to 12 years experience? Next, we're going to read from a file. This class will be called file reader, which is an input stream that reads from a file. Name the object read file equal new file reader. The file is located in the current path directory. So we write, path directory and / read file test.txt. We're going to read from this file, but have to also scan the file. The purpose of scanner is to receive input. Let's also import this java.io package for file reader and write scanner, scan equals new scanner. Which file? The read file. Let's try a quick test and print the first line. Write sysout scan dot next line. Let's run. Joe Doe. Perfect. Now let's read the complete file. While scan has a next line, let's also print the next line. Let's run. Every single line for John Doe
And Jane Doe is displayed in the console. Let's make sure the file showed up in the Package Explorer. Bingo, it showed up. Joe Doe, Jane Doe. That's it for Java input and the Java output. And I'll see you in the next video. Don't forget to subscribe to my channel. And when you subscribe, click the bell icon to get notifications of each video. Connect with me on LinkedIn, follow me on Twitter, and also connect with me on Facebook. I have so many more videos for programming and automation, and I think you'll like what's coming up soon. Thank you. What is a package? A package operates like a folder with files related to each other. In this case, the related files are classes. Every package maintains two purposes. First, it organizes classes as one unit, and second, it controls access to members of a class. A class defined within a package must be accessed through their package name. Access to members of a class, such as variables and methods, are carried out using access modifiers. In this session, we are going to look at package convention and package creation. In Eclipse, we have SRC, which is the source folder that contains source files for our project. It has 5 packages. A package can have sub-packages. Under com.selenium for beginners, I have Java, Selenium Test NG, and utility as the sub-packages. Here's a set of related packages and 3 classes under Java. There's a lot of classes under Selenium Test NG. When it comes to the package convention, if we do not include a package name, then the class goes to default package. For example, right-click SRC, new class. The package field is blank, but we see default in parentheses. This is not recommended. Look what happens when I write class 1 for class name. A warning shows the use of the default package is discouraged. Click finish, and we see class 1 in the default package. Notice how line 1 is blank. I'm going to drag class 1 to Java. Now, line 1 shows a package statement. To create a package, we right-click SRC, new package. By convention, packages must begin with a lowercase letter. If I write capital D for demo package, the warning shows discourage package name. By convention, package names usually start with a lowercase letter. Click finish. It's not wrong, but not recommended to start with an uppercase letter. Delete demo package. Do you see how com.selenium for beginners is different than the other packages? Some projects use a reverse website domain as their package name. If I had a domain called domain called seleniumforbeginners.com, then in reverse, my package would be com.seleniumforbeginners. The dot creates a sub package. Let's create a sub package under Java. Right click Java, new package. Add a dot after Java, then demo package 1, and click finish. Drag class 1 to demo package 1. Dialog shows update references to class1.java. Hit OK, and I realize I misspelled package. So I'm going to right click package 1 and I'm going to refactor, rename. And I'm going to add the E to package and click OK again. Now we see the package has been updated in the statement and in package Project Explorer. The package statement updated to demo package 1. Do you see that? That's it for packages and organizing our classes. Next, I'm going to show you how to access the control features using all 4 access modifiers. And I'll see you in the next video. If you like this video, consider subscribing to my YouTube channel, follow me on Twitter, connect with me on LinkedIn, Facebook, because I have a lot more videos to show you. Just wait, and I have so much more content. And thank you. The 4 access modifiers are public, protected, default, and private. This is the order of their access level. Public can be accessed by code outside its class. Protected is accessed by code outside its package and by code inside its package. If the code is outside its package, then it must be inside of a subclass. Default can only be accessed by code in its package. Last is private, which can only be accessed by code in its own class. Let's pick back up where I left off with packages. A demo package was created under Java. Now I'm going to create one more package. Right-click Java, new package. Demo package 2. We are going to create 3 more classes. Right-click demo package 1, new class. Name will be class 2. Click the checkbox for public static void main. Right-click demo package 2, new class. Name will be class 3. Click the checkbox for public static void main. And the 4th class will be under demo package 2. Name will be class 4. And click the checkbox again. In the same class, all access modifiers are visible: public, protected, default, and private. For class 1, let's write our data variables according to their access level. As a comment, I would write public, protected, default, and private. Same class. First is public int, age equals 20. Second is protected string, birthday equals 02/2020. Third is default, which has no access modifier. Int experience equals 10. Fourth is private. Int ID equals 1, 2, 3, 4. Did you notice the difference in symbols for each access modifier under class 1? Public is a green circle with a white dot. Protected looks like a yellow diamond. Default is a blue triangle, and private is a red square. Let's add some print statements to show the access for each variable inside of a main method. Know what? I have to make the variables static to print their value in the main method. Static for age, public, static for protected string, and default, experience, and private ID. Starting with age, we're going to write sysout public. age equals the variable name age. Next is sysout protected birthday equals, and the variable name birthday. Third is default. So we write sysout default experience equals the variable name experience. Fourth is private. So we write sysout private ID equals the variable name ID. Let's run. And we see all of the values: age, birthday, experience, and ID in the same package, but different class. Private will not be visible. Let's copy the comments from class 1 and go to class 2 and paste it. Remove private and change same class to same package. Public protected default. There is no need to create an object because the variables are static. You know what? Let's go ahead and remove static from these variables. Copy the print statements and make them a comment. Go to class 2 and create an object. Class 1 obj equals new class 1 obj dot, and we see 3 of the 4 variables: age, birthday, and experience. Private ID is not available. So we go ahead and add the print statements. Add obj in front of each variable: obj.age, obj.birthday, and obj.experience. There's no need to put obj in front of ID because it's not visible. So let's remove this print statement and run. We see age, birthday, and experience. Access modifiers get interesting when dealing with a different package. Only public and protected are visible in a different package. However, protected members are only visible if accessed through a subclass. Go to class 3, and we're going to write as a comment public protected. Different package sub class. We extend class 3. Class 3 extends class 1. Import class 1. Then create an object. Class 3 obj equals new class 3 obj dot. We only see age and birthday, which are the public and protected variables. Let's copy those print statements again, but this time from class 2, and paste them. Let's run. We see age and birthday. Only the public access modifier is visible to the entire project. That includes the same class, same package, different package inside the subclass or inside the superclass. Go to class 4. And write, uh-oh, I clicked the wrong button. That was a mistake. As a comment, write public entire project and extends class 1. Create an object from the superclass this time. Class 1 obj equals new class 1. Obj dot import class 1 dot, and all we see is age. Print statement sys out public age equals, then add the obj object name and access age. Let's run. We see age equals 20. This video applied to access modifiers to variables, but it works the same for methods. That's it for access modifiers. If you're interested, subscribe to my YouTube channel, then click the bell icon. The bell icon lets you know when I release a new video. You can also follow me on Twitter, connect me on LinkedIn and Facebook. I have so many more videos to show with our community regarding automation and programming. And I'll see you in the next video. In this session, let's talk about constructors. A constructor is a special method that initializes values when creating an object. All classes have constructors because Java automatically provides a default constructor. There are two types of constructors: the default constructor and parameterized constructor. Starting with the default constructor, also known as no-R constructor, we have 3 comments. Constructors initialize the object when creating the object. Constructors have the same name as the class name, and constructors have no return type. We have a field called student ID and student name. In addition, there's a method called display student info. The method will print the student ID and print the student name. We are going to test the default constructor by creating an object. An object is created using the keyword new for a new student. To access the new object, we must assign the object to a variable of type student with the variable name of student1. Now we can use our object. Let's call the method student1 dot display student info. Before assigning the values, the default constructor initializes default values. Numeric types default to 0. Reference types such as string default to null, and Boolean default to false. Let's run. As expected, student ID is 0 and student name is null. The values are 0 and null because they do not have a value yet. Now let's initialize our own values. How do we define a constructor? We define a constructor just like a method, but with the same name as the class name. We write public student. Notice there is no return type such as void. Declare student ID equal to 12 and student name equal to Mary. How about a print statement? Sys out, execute, constructor. Okay. Now, let's go back to the test class. Line 7 creates the object, sets the values, and show us how the constructor will be executed when creating the object. Let's run. We see execute constructor, student ID equals 12, and student name is Mary. Now, let's take a look at the parameterized constructors. The parameterized constructors has the same concept as the default constructor. Initialize the object when creating the object, same name as class name, and do not have a return type. However, this type of constructor accepts values from its parameters. We add parameters to a constructor in the same way as a method. Write public students int ID string name. ID and name are the parameters. Assign ID to student ID and name to student name to name. Print statement sys out student ID and name. We can have as many constructors as we want. Just change the parameter list. Also, if we choose to, we can bypass writing the access modifier and only write the class name students. If I spell it right, there it is. Either way, it's okay. We can write public or without public. This time, our constructor only includes int ID. Let's send some values to these constructors. When I write student ID equals ID and print statement of sys out student ID. Sending values, we're going to write students. Please forgive my typing in this video. New students. Do you see the error? We have an error because an empty student constructor is not defined. The first and second quick fix want to add an argument. Select the second quick fix. And we see 0 and null. Replace 0 with student ID of 34 and replace null with James. Call the method student2 dot display student info. Let's create one more object. Student3 equal new students. 56. 56 is the student ID. Let's call the method student3 dot display student info. Let's run. Student ID and name. Student ID is 34 and we see student name as James. Student ID is 56. Student name is null. It's null because the constructor did not have a student name. That's it for constructors. If you are new to my videos, consider subscribing to my channel and clicking the bell icon. You can follow me on Twitter, connect me on LinkedIn and Facebook. Also the code. And transcript will be added to GitHub. And I'll see you in the next video. Let's talk about a Java keyword called this. Do you see our fields named student ID and the student name? They are fields also known as instance variables and sometimes called global variables. Java has three types of variables: instance variable, class variable, and local variable. In some cases, you may hear a parameter mentioned as a parameter variable because the value can change. This program has two fields, aka instance variables, with the same name as two parameters, student ID and student name. There's confusion when a program has an instance variable and local variable with the same name. To avoid confusion, we use keyword this, which refers to the instance variable. Therefore, we write this dot before student ID equal to student ID, and this dot student name equal to student name. Do you see the color of each word? The color gives us a tip regarding which one is the instance and which one is the local. Another tip is clicking the variable. If I click this dot student ID, then the instance variable and this student ID both highlight. The same happens when clicking student ID inside the parentheses. We see student ID without this dot highlight. We use keyword this inside constructors and methods. It's not required to have an instance variable and local variable with the same name. We can choose to provide different names. For example, I would create another constructor and name it public student with two parameters: string stud name, int stud ID. Now, when I write this here, this dot student name, it will equal stud name. The names are not the same. Also, if we wanted to, we can leave off the keyword this by writing student ID equal to stud ID. However, it's best to be consistent. You can make both words the same and write keyword this. You can make both words different or write keyword this when both words are not the same. Either way, just be consistent with your program. Personally, I like my naming convention to be descriptive, so I picked the first two syntaxes. Also, using the keyword this prevents discrepancies, limit redundancy, and increase readability. Let's test our program by creating a method called public void display student info. Sys out student ID equals plus this dot student ID. Let's skip a line and we're going to add student name equals this dot student name. We're going to skip a line one more time by backspace N. Let's also create another class. Right click, keyword this, the package, new class. The name will be test this keyword. Click the checkbox for main public static void main. Student student 1 is the object, new student. Constructor would be student ID and student name. Student ID is 1, 2, 3, 4. Student name is Mary. Object student 1 dot display student info. Let's create one more object for student 2, new student, and this time we will select stud name and stud ID. Stud name will be James. Stud ID will be 5678. Let's write the object and call the method display student info. Now let's run. The console shows the correct information, student ID and student name. That's a quick video on the keyword this. If you like the video, consider subscribing to my YouTube channel and clicking the bell icon to receive notification. Also, click like on the video. You can also follow me on Twitter, connect with me on LinkedIn and Facebook, and the code and transcript will be available on GitHub. And I will see you in the next video. The keyword super refers to the superclass. It allows us to access the superclass variables, methods, and constructors. Here's a scenario where the superclass is inherited by the subclass. I like to say parent class and child class. The parent class does not have a defined constructor. Therefore, a default constructor is provided automatically by Java. You can watch my constructor video for more information on constructors. If we look at the child class, it also does not have a defined constructor. A constructor rule states a subclass constructor must invoke the superclass constructor, whether the superclass constructor is implicit or explicit. That means if there is a constructor in the parent class, then the child class must call that constructor in the parent class. In this scenario, both the parent class and child class have implicit constructors because they are not defined. Now, look what happens when I add a defined constructor to the parent class. I'm going to write public person, add a parameter for int ID. This dot ID equals ID. Look what happens when I save. There's an error in the child class. The error message states implicit superconstructor person with no parameters is undefined for default constructor. Must define an explicit constructor. That means the child class must have a defined constructor because the parent class has a defined constructor. In the child class, let's write public student, add some parameters for string, name, and int ID. Now we have a different compiler error. The error states implicit superconstructor person undefined must explicitly invoke another constructor. This is where the keyword super comes into play. We must invoke the superclass constructor using the super keyword. So we write super, control space, and we see a parameter for int ID. Select that option and the error goes away. If I write this dot name before super ID, we have a different error. Hover super ID and the message states constructor call must be the first statement in a constructor. Whenever we call a constructor, it must be the first statement. So we add super ID before this dot name equals name, and the error goes away. There are two ways to use the super keyword. This is one way, where we call the superclass constructor. The second way is to access members of a superclass that has been hidden by the subclass. Now we see two methods, getter and setters. Getter ID for get ID getter method, set ID for setter method. In the subclass, hide the getter ID in the superclass and setter ID, set ID in the superclass. Let me show you how to access these superclass getter and setter methods. Go back to the child class and write public string display student information. Return personal ID. Get ID. Do you see student? This would call the subclass student method. We want the superclass person method. Therefore, we write super dot. And now we get ID for the superclass person method. We can also add a method from the subclass, child class. This example can have personal ID and it can have student ID. So I'm going to write student ID and call the ID from the child class student. There we go. A superclass variable operates just like a superclass method. However, the variable and method must be a public member. That's it for super keyword. You can follow me on Twitter, connect with me on LinkedIn, and subscribe to my YouTube channel. And the code will be on GitHub. And I'll see you in the next video. In this session, let's talk about data type conversions and data type casting. Both involve changing the data type from one data type to a different data type. However, the difference depends on their compatibility. A data type conversions happens automatically with compatible data types. If the data types are, then we must apply a data type casting. We are not changing the value, but only converting the value. In Eclipse, let's start with the data type conversion, which can also be called widening conversion. Widening conversion is when a smaller data type is converted to a larger data type. It gets wide from small to large. For numeric data types, the precision goes from byte, short, int, long, float, double. Byte is the smallest numeric data type, and double is the largest data type. If our data types are from left to right, then the compiler automatically converts the types. Two things must happen for an automatic conversion. Both data types must be compatible, and the destination type must be larger than the source type. Look what happens when the destination is smaller. Int destination. Int is a whole number and smaller than the source 34.56. 34.56 is a double. Therefore, the error message states type mismatch, cannot convert from double to int. Let's add a comment that says cannot convert from double to int. Now, look what happens for the automatic conversion. We write int source 1 equals 34. Double destination 1 equals source 1. Source 1 is smaller than destination 1 because int, it has a lower precision than double. Let's print the values. Sys out original int value plus source 1. Sys out widening conversion int to double plus destination 1. Let's run. Original int value is 34 and widening conversion int to double is 34.0. The value on the right, which is source 1, automatically converted to the double data type destination 1 on the left. So we see 34.0. Next is data type casting, which can also be called narrowing conversion. This type of conversion happens when the destination type is smaller than the source type. We write double source 2 equals 34.999. Int destination 2 equals 34.999. This is the same error from last time. Type mismatch cannot convert from double to int. We have to explicitly carry out the conversion. We specify the data type we want to convert inside the parentheses. Casting takes place when we send an instruction to the compiler to convert the data type. Let me say that again. Casting takes place when we send an instruction to the compiler to convert the data type. The cast always happens before the value. Therefore, we place int for int inside the parentheses. A person might think the value 34.99 would round up to 35, but that's not true. It will convert to an int value. However, the decimal and 999 will cast off and not be shown. Let me change 34.99 to source 2 and add some print statements. Sys out original value double plus source 2. Sys out narrowing conversion double to int plus destination 2. Let's run. Original double value is 34.999. The narrowing conversion double to int cast off 0.999 and only show 34. In the next video, I am going to convert an object to a variable and convert a string class to a numeric value. You can connect with me on LinkedIn, YouTube, Facebook, and GitHub, and Twitter. On LinkedIn, I release videos like every day. If it's not a video, then it'll be a transcript. On Facebook, I release videos. On YouTube, you can subscribe to my YouTube channel and click the bell icon. And my goal is to start and continue releasing videos every Monday, Wednesday, and Friday. And I'll see you in the next video. Let's pick back up where we left off with data type conversions and the data type castings. Start by converting an object to a variable. Double source 3 equals 12.12. Source 3 is an object, and we cannot cast an object. It works different than the previous example, int destination 2 equals int source 2. Let me show you. Int destination 3 equals int source 3. See the error? Cannot cast from double to int. Notice the difference between both double data types. One D is uppercase and the other D is lowercase. And uppercase D represents a class and the lowercase d is a primitive data type. We must use a method from the class to perform a conversion. Java provides a corresponding class for each primitive data type. Remove the cast int and keep source 3 but add a dot. And we see all of these methods from the double class. Int value returns the double value represented by source 3. Then convert the value to type int. Now the error goes away. This is how we convert an object to a variable. The object source 3 and the variable destination 3. Let's add some print statements. I'm going to separate each section by adding another statement of horizontal lines. 1, 2, 3, 4, 5, 6, 7. Copy and paste in this section. The print statement will be sysout original double object value source 3. Sysout convert object to int variable plus destination 3. Let's run. Bingo. Original double object value is 12.12. Then convert the object to int and the value is 12. Now let's convert a string to a number. String source equals 100 in double quotes. Double destination 4 equals double dot. Parse double returns a double value representing the string 100. Then we select source. In the same way, we can parse an integer. Parse means it is analyzed for the correct syntax. Integer destination 5 equals integer dot parse int. Select source. This method returns an integer. Let's print the values. And I'm going to copy. No, I'm going to just type them out. Sysout original string value plus source. Sysout convert 2 double plus destination 4. I'm going to copy and paste this line and change double to integer and change destination 4 to 5. Now let's print. There it is. As expected, we see original string value is 100. When converted to a double, it's 100.0 and 100 when converted to an integer. That's it for data type conversions and castings. You can connect with me on LinkedIn, YouTube, Twitter, and Facebook. And the transcripts and code and presentations, I always put them on GitHub. For LinkedIn, I release videos just about every day. Transcripts also on LinkedIn. On YouTube, videos are released and created on Monday, Wednesday, and Fridays. The same with Facebook. And I'll see you in the next video. And don't forget to subscribe to get notification of each video by clicking the bell icon. And I'll see you next time. Let's talk about the keyword final. Final is a way to prevent variables, methods, and classes from changing in our program. Variables are considered constants after applying final. A method cannot be overridden after applying final. When final is applied to classes, the class cannot be inherited by another class. Starting with variables, we write final before the data type int. Conventionally, the name is written in all capital letters. Capital letters identify the variable as a constant, meaning it will not change. There are 24 hours in a day. The difference between final and non-final variable is a final variable cannot be reassigned. For example, let's create a method called public void display daily hours. Hours equal 25. Do you see the error? The error states hours cannot be assigned. Look what happens when I remove final. The error goes away. Change the value from 25 to 24. Then add final back. And the error comes back. The error comes back because we are only allowed to initialize a final variable one time, either directly or inside a method. Final also prevents method overriding. Let's see what happens when I go to this other class, test final time. Extends the parent class. Time is a terrible thing to waste. Then override the method by clicking Control Space and navigating to display daily hours. You see, there is no problem. But if I go back to the parent class, then add final to the method after public and save, now we see a different error inside the child class. Not different error, but now we see an error in the child class. Hover the error, and the error says cannot override the final method. Declaring a class as final implicitly declares all of its methods as final. A final class prevents inheritance. If I add final between public and class, then we see an error that's different from the previous error, and it says cannot subclass the final class. To recap, let's go over this again. Final variables cannot be changed because they are considered constant variables. Final methods cannot be overwritten, so they prevent method overriding. And final classes cannot be subclassed, so they prevent inheritance. Thanks for watching. If you liked the video, consider subscribing to my channel and clicking the bell icon to receive notification of each video. Also, like the video. I'm also open to networking on LinkedIn, Twitter, and Facebook. And the code and transcript will be available on GitHub. And I will see you in the next video. In Java, a string is a class that represents a sequence of characters. Therefore, the word or the phrase is surrounded by double quotes and contains several methods. We can create a string by writing string username equals new string. Then pass in a literal like software engineer 34. However, most engineers create their own string by writing string with an object like name equal to a value such as Rex Jones II. Let's print both string values. Sysout user name. And then we're going to write the object username. Let's also skip a line and write name for the name object. Let's run. We see username software engineer 34 and name Rex Jones II. Okay, let's look at some methods for string. Hover over string, then click open attached Java doc in the browser. First thing we see is class string. Scroll to the method section. There are a lot of methods. Char at, concat, contains, equals ignore case, format, index of, last index of, length, replace. Okay, let's go back to our program and use some of these methods. To convert all of the letters for name to lowercase, we write sysout name lowercase name dot, and we see some of the same methods we just saw in Java docs. Select lowercase. There's also a method to convert all of the letters to uppercase. Copy and paste and change lowercase to uppercase and change dot to lowercase to dot uppercase. Let's run. The console shows my name in all lowercase letters and uppercase letters. Next, let's look at the length method. It would return the number of characters in my name. Should be 12. Paste and change lowercase to length. Change dot name dot to lowercase to name dot length. And run. We see 12 for the length. There is a way to take a portion of a string using the substring method. For example, I can print only the first name by writing substring. There are two methods. One method receives one argument and the other method receives two arguments. Let's select two arguments. Begin index will start at 0. The end index is tricky. A person may think the end index should be 2 because x is the second index, or ex, but we need the end of the index, which is 3. Therefore, we enter 3 for the ending index. Change lowercase to substring and run. Rex. A popular method for string is char@. It returns the value of our index. Let's get the first letter by writing sysout name first character. Name dot to lowercase would have changed to name dot char@. Add 0 and run. You know how the length is 12? If we enter an incorrect index, such as 13, let me make this right. There we go. Such as 13, then we will get an exception. String index out of bounds exception. String index out of range 13 is out of range because 12 is the length. Change it back to 0. Let's look at a few more examples. How about contains? Contains returns true or false if the string has a certain value. Sysout, and we're going to write name contains Jones. Change name dot to lowercase to name dot contains. JONES. Let's run. The console returns true. Another popular method is equals. Sysout name equals Rex Jones II in all capital letters. Name dot equals. There it is. Rex Jones II. Let's run. This time, the console returns false because the string is not in all capital letters. Rex Jones II is uppercase and lowercase. If you want to ignore the case, then we can write equals, ignore case, would have returned true because it would ignore the case. One more string. How about string.format? This method returns a formatted string using a string and an argument. The argument would be string nickname. Nickname James. James is the name I was actually born with, James Allen Jones, but it was changed to Rex Allen Jones II about 2 or 3 days after I was born. Sometimes I still go by James Jones. Sysout string.format. The string is my nickname is %s. %s lets the compiler know to print out a string and the argument is nickname. Let's run. Our value was concatenated because two strings are joined together. The plus signs are a form of concatenation because it also joins two or more strings. You know what? That's it for strings. My nickname is James. I will add a link to the transcript and source code in the description. You can follow me on Twitter, connect with me on LinkedIn, Facebook, and subscribe to my YouTube channel. If you're interested, click the bell icon to receive notification of each video. I still have more content, so I will see you next time. Thank you. The keyword throw is used to manually throw an exception. Videos 81 and 82 introduce you to exceptions and how to handle the exceptions. An exception shows there is a problem with our program. So why do we want to manually throw an exception if it shows there is a problem? Manually throwing an exception allows us to handle the problem in our code as part of the overall handling exception strategy. Most of the times, the exception we throw will be an instance of an exception class that we create. In Eclipse, I have a class called Demo Throw with two methods, divide numbers and the main method. The divide numbers method has int dividend equal num1 divided by num2 and a print statement. The main method will pass 100 to num1 and 10 to num2. Let's run. The console shows what is 100 divided by 10. 10 is the answer. That's cool, but what if we pass 0 as num2? Then run. Now we see an exception. Arithmetic exception divided by 0. Manually throwing an exception, or we can say explicitly throwing an exception, allows us to handle this problem and customize the exception. Place these two statements in an if block. If num2 is greater than 0, then paste both statements. Write else. First, we write keyword throw, then new, followed by the exception, arithmetic exception. Customize the exception by writing cannot divide by 0 or less than 0. The keyword throw is how we manually throw this arithmetic exception. Run again. We see the same arithmetic exception with the customized message. Cannot divide by 0 or less than 0. Our message provides more information to the user. This was an intro to keyword throw in Java. I plan to show you how two keywords, throw and throws, work together to make our program complete. Don't forget to subscribe to my channel, follow me on Twitter, connect with me on LinkedIn and Facebook, and I'll see you in the next video. When it comes to the keyword throws, we must declare one or more exceptions in a throws clause if the method generates an exception and does not handle the exception. The responsibility of handling the exception falls onto the calling method. In the previous video, I mentioned the keyword throw is used to manually throw an exception. Let's look at throw and throws. Under class 1, I have a method called divide numbers that receive two integer arguments. Num1 gets divided by num2, and the value is assigned to dividend. Dividend is returned to the calling method in class 2. We see under class 2, I created an object called obj. Obj calls the divide numbers method in class 1, then pass 150. When I execute, we see 2 is returned to the console. Suppose I change 50 to 0. In the previous video, we saw an exception will show up because a number cannot be divided by 0. Let's run again. Did the exception happen in class 1 or class 2? The stack trace shows us arithmetic exception divided by 0 and class 1 divide numbers. When the exception happened, the code was running in class 1. However, class 2 must handle the exception because it sent the values 100 and 0. Let's handle the exception by surrounding dividend equals num1 divided by num2 with the try statement. In the catch statement, exception, we write a print statement, sysout, for class 1. Throwing back an exception to class 2. At this point, class 1 does not know how to handle the data because class 2 is sending data that's causing a problem. Let's rethrow the exception by throwing back an exception to the calling class with the customized message. Throw new exception. Can you check your numbers? Here's where we implement the throws keyword. Notice there's a compiler error. Hover the error and we see add throws declaration. Select it. And throws exception is added to our method signature. Saving class 1, cause an error in class 2. Class 2 has an error because it's calling the divide numbers method. The divide numbers method indicates it may throw an exception. Therefore, class 2 has to handle the exception that class 1 throws back. Hover the error and select surround with try catch. Print the message sysout class 2. I almost misspelled class, didn't I? Get message. Now let's run. We see class 1 throwing back an exception to class 2. Class 2, can you check your numbers? To recap, class 2 calls the divide numbers method in class 1. Class 1 receives values 100 and 0, which causes an exception. It tries the numbers, then catch the exception. After catching the exception, class 1 throws a new exception with the message that's sent back to class 2. The throws keyword is used in the method's signature because the method may throw an exception. We can add warn or more exceptions separated by a comma. That's it for both keywords throw and throws. Throw is used to mainly throw an exception, and throws is declared in the method signature to declare an exception that might get thrown. That's it for throw and throws. Follow me on Twitter, connect with me on LinkedIn, subscribe to my YouTube channel because I have a lot more tutorials, demos to show you for programming and automation. And I'll see you in the next video. What's the difference between Java's finally and final keywords? The difference is keyword final is used to protect variables, methods, and classes from changing in our program. Reserved word finally is defined as a block of code that executes after exiting a try-catch block. Variables marked final cannot be reassigned. The value can only be initialized one time. Final methods cannot be overridden. If we make an attempt to override a final method, then we receive a compile time error. We also receive a compile time error when making a class final, then trying to extend the class. The error message says cannot subclass the final class. Keyword finally is different because it deals with try-catch blocks. The purpose of a try-catch block is to handle an exception. An exception is a problem with our program. The try block is used to monitor code that may cause an exception, while catch is a block of code that's used to handle an exception if an exception is thrown. The finally block will be executed automatically when execution leaves a try-catch block. It will execute if there is an exception, not an exception, or return from the method. That's it for the difference between final and finally keywords.
All Part 1 ebooks and PDF documents are free. Programming books for UFT. Programming books for Java. Here's the Selenium Automation book. And TestNG. Subscribe to get notification of future videos. Don't forget to like, comment, and share.